For centuries, Mars was just a red dot in the night sky, a distant world we could only imagine. But today, with orbiters circling above and rovers moving across its surface, we've turned that mystery into data. We've mapped its valleys, studied its storms, and even uncovered evidence that water once flowed across its surface. And yet, despite everything we've learned, Mars continues to surprise us. Recently, something completely unexpected was detected. Not a massive discovery, not a dramatic image, but a tiny sound. A faint crackle so small it could have easily been ignored. And yet, that single signal might be the first real evidence of lightning on Mars. This discovery came from NASA's Perseverance rover, a machine designed to search for signs of ancient life, collect rock samples, and study the planet's geology. One of its key instruments, SuperCam, fires a laser at rocks and listens to the sound waves produced. It's essentially hearing Mars. But while doing this routine task, it picked up something unusual, a soft popping sound, then more of them. At first, these sounds didn't seem important. They could have been caused by dust hitting the microphone or internal noise from the rover itself. But when scientists looked deeper into the data, they noticed a pattern. These pops were not random. Most of them occurred during dust activity storms, gusts of wind, and dust devils moving across the Martian surface. That's when scientists started asking a new question. What if these sounds weren't noise at all? What if they were electrical? On Earth, lightning forms when particles inside clouds collide and build up electrical charge. Eventually, that charge becomes too strong, and it discharges as a bolt of lightning. But lightning doesn't only happen in clouds. It can also occur in dust-filled environments. Volcanic eruptions on Earth, for example, often produce lightning due to ash particles colliding and generating static electricity. Mars is the perfect place for this. Its surface is covered in extremely fine dust. Winds constantly lift this dust into the atmosphere, forming dust devils that can reach heights of up to 20 kilometers. Some estimates suggest that millions of these dust devils exist on Mars at any given time. On top of that, Mars experiences massive dust storms, some so large they can cover the entire planet for weeks. These conditions create constant friction between particles, and friction creates charge. To test this idea, scientists recreated Martian conditions here on Earth. They used similar dust particles, simulated atmospheric conditions, and instruments like the one on Perseverance. When they generated static discharges, the sounds they recorded were nearly identical to the crackling noises detected on Mars. This was a huge moment, because it meant that Perseverance may have accidentally recorded the first direct evidence of lightning on Mars. Not in the form of bright, visible flashes like on Earth, but as tiny electrical discharges happening within dust storms. And while that might sound small, the implications are massive. On Earth, lightning plays a crucial role in atmospheric chemistry. It breaks apart molecules like nitrogen and oxygen, allowing them to recombine into new compounds. These reactions are essential for maintaining the balance of our atmosphere. Some scientists even believe that lightning may have contributed to the formation of the first organic molecules that led to life. Now consider Mars. The planet is known to contain highly reactive chemicals such as hydrogen peroxide and perchlorates. These compounds are extremely harsh and can destroy organic material. For years, scientists have struggled to fully explain how these chemicals are formed in such abundance. This is where Martian lightning could be the missing piece. Even weak electrical discharges can carry enough energy to break molecular bonds and trigger chemical reactions. Over time, millions of these tiny discharges could significantly alter the chemistry of the Martian surface. And that leads to a major implication. If Mars once had life, these chemical processes may have erased the evidence. Organic molecules could have been broken down long ago, leaving behind a surface that appears lifeless even if it wasn't always that way. This means that the search for life on Mars becomes even more challenging. Instead of focusing only on the surface, future missions may need to dig deeper, exploring underground layers where evidence could still be preserved. But the impact of this discovery goes beyond science. It also affects the future of human exploration. Dust on Mars is already a major problem. It sticks to surfaces, covers solar panels, and interferes with equipment. When that dust becomes electrically charged, the problem becomes even worse. It clings more strongly and behaves unpredictably. We've already seen the consequences of this. NASA's InSight lander gradually lost power as dust accumulated on its solar panels. Eventually, it stopped functioning completely. Now imagine similar conditions affecting a human mission. Life support systems, instruments, and habitats could all be impacted by charged dust and constant electrical activity. Even though Martian lightning is likely too weak to directly harm astronauts, it could still interfere with electronics and long-term operations. This turns what seemed like a minor discovery into a serious engineering challenge. And what makes this even more fascinating is how it was discovered. Not through a dedicated mission, not through a specialized instrument, but by accident. Perseverance wasn't even looking for lightning. It was focused on rocks, on geology, on signs of life. And yet, in the background, it captured something completely unexpected. This raises a bigger question. If something this important went unnoticed for so long, what else are we missing? Mars has been explored for decades. We've sent orbiters, landers, and rovers. We've collected data, images, and samples. And still, the planet continues to surprise us. A tiny crackle, a small spark, a signal that changes how we see an entire world. And this is just the beginning. Because as we continue to explore Mars, one thing becomes clear. We don't fully understand it yet. And maybe that's what makes it so exciting. Every mission, every signal, every unexpected discovery brings us closer to the truth. Not just about Mars, but about the possibility of life beyond Earth.